So let's talk about slope and the rate of change. Okay, so when I'm talking about slope, I generally mean an incline of some sort, right? Something where you're going up. Okay, so things like a ramp, like maybe this is a ramp going upwards, or maybe it's part of a roof, like that, or maybe it's just part of a triangle, if we're just doing some pure math here. But the important part is that it goes up and it goes across, right? So it goes up some distance, and it's also going across some distance. Okay? When we're talking about slope, we call these the rise and the run. Think about it like it rises up and it runs across, like you would run across a room. Okay? So where the rate of change part comes in is that a slope is a rate of change, or in other words, how quickly one variable changes in relation to another one. Right? So in this case, it's how quickly does this slope go up, how quickly does it rise, in comparison to how it runs. Okay? So if we compare those, if we were to put this into an equation, we could make a rate that looks a little bit like this. We get slope equals the rise over the run. Okay? And it's just a simplified way of saying the slope equals the change in height over the change in horizontal position. Right? Much easier to say rise over run. Okay? So if we have the rise and the run of a certain slope, then we can calculate that slope. So let's take a look at that. Let's say we have a ramp here. That's just an entrance ramp. Let's say that the rise we have is 2 meters. So there's 2 meters to get up to this door up here. Okay, so that's 2 meters off the ground. And the ramp starts, we'll say 12 meters away. Okay, so we know that this is our rise, how much it goes up, and this is our run, or how much it goes across. Okay, so to find our slope, all we have to do is we take slope equals rise over run, which will be slope equals the rise of 2 meters over the run of 12 meters, which if we calculate that, will give us a slope of 1.6 repeating. Okay, notice the units disappear since they cancel, but it'd also technically be correct to write meters per meter, since that's what's really happening. It's going up a certain number of meters while it's also going across a certain number of meters. We just tend to write slopes without the unit. Okay, now we can take this equation, because that's all well and good, but realistically we don't always need the slope of something. Sometimes we need to know how long something is or how high something is. So let's say that we wanted to keep the same slope. Maybe this is a good slope for someone who is using a wheelchair, or someone who is using crutches, or somebody who is using a cane, that kind of thing. Maybe this is the kind of slope that we want to make sure that they don't trip and fall or fall backwards. So if we wanted to keep that same slope, but instead I'll do it in blue here, we have a new door that is quite a bit further up. We'll say that this one is 4 meters up, right? And we know that it's probably going to take longer to get up there, so I'll make it a little bit longer. But we want it to be the same slope, right? So the slope is still 1.6. Repeating. We want to know, well, how long is it going to take to get there? How far out does this ramp have to be? All right, this should be a common engineering question if you're trying to figure out how long a ramp needs to be to get up to a certain point. So we just rearrange the equation. Okay, and there's a trick to do this. I like to call it a magic triangle. Okay, so anytime that you have an equation that looks like this, where you have something equals something over something else, like in general it would be A equals B over C, then you can draw the magic triangle. So the magic triangle looks like this. You've got a triangle form here. Whoops. Doop, doop, doop. Subdivided like this guy. And for slope, we've got slope equals rise over run. Okay? And we just have to know that this horizontal line means division. This vertical one means multiplication. So division, multiplication. And all we do is we cover up the thing we're trying to find, and that will give us the formula to find it. So in this case, we've got the rise, we've got the slope, we're looking for the run. So we cover up the run, just cover it up here. Normally I just do this with my thumb, but you can't see that on a screen recording. So you cover up the run, and you're left with rise and slope, with the horizontal line between them. And since the horizontal line means divide, we know that the run, the thing we're looking for, must equal the rise divided by the slope. And if we just finish up that calculation real quick here, we get the rise over the slope, which is 4 meters divided by 1.6 repeating. And if we do that calculation here, so run will equal 2.4 meters. Okay, so you can use that same strategy for rise, slope, and run. Again, just cover up the thing that you need, and you'll find how to get it.